Okay, I'm going to show you a couple of factoring problems and a method that I use to break these trinomials apart. Whenever the coefficient of your squared term is just 1, it's not as difficult of a puzzle, but you are trying to do the reverse of the FOIL method and break this into its two factors. If it's just a 1 here, you can simply put an x times x to be the x squared, and then think about numbers that multiply to be negative 50 but add to be negative 5. And that's what will belong here. Again, multiply to be negative 50 and add or combine to be negative 5. Now again, that's only if it's a 1 here. Otherwise, you have to multiply the first and the last together, which we'll see in the next example. But anyway, what multiplies to be negative 50, we could use a 2 times 25, 5 times 10, what else multiplies to go into 50? So you can go through the different combinations. What works to add to be negative 5 is negative 10 and positive 5. So negative 10 times positive 5 is negative 50, and then when you FOIL, first times first is x squared, the last times last is negative 50, so you really only have to check your inner and your outer combined to be the correct middle term. So once again, if this is just a 1, you only have to focus on the last number, what multiplies to be that, but adds to be the middle. Well, a lot of times we have more complicated problems with different coefficients, such as this next example. Let's say we have this trinomial. And we're trying to find how this breaks apart. You can always use trial and error, and if that is working for you, just guess and check until you get the right combination that foils back to be this. That's a fine method. Honestly, that's how I usually will do these. But here's a more methodical way that helps students that are having trouble with this puzzle. If you have a coefficient other than 1, you have to multiply the first and the last together before you proceed. So the 7 times 6 has to multiply to be 42, and it's going to be x squared. So the first times the last, some people call this the rainbow method or the master product method. It has some different names you might find. But multiply the first and the last. Then you need something that adds to be the middle, which is the same thing I said on the last example, only because the first coefficient was 1, 1 times negative 50 is just going to be the last term, negative 50. But this really does apply to all. The first times the last, positive 42x squared, and then adds to be the middle. So you think through ways that you can multiply and get 42, maybe 1 times 42, but that does not add to be negative 23. You need to add to be negative 23 and multiply to be 42x squared. Also notice I need it to multiply to be a positive, but then it needs to add to be a negative, which tells me the signs must both be negative. A negative times a negative will be a positive when you multiply, but add to be a negative. All right, that doesn't work, so I'll go on down to 2. 2 times 21 is 42. And there it is. Those multiply to be positive 42 and add to be negative 23. So I'm going to put x's on it so the variables work out as well. Negative 21x and negative 21x and negative 2x do multiply to be 42x squared and do combine to be negative 23x. Once you determine what works, and I don't even need to go on, try 6 and 7 and other things, that's what works. Then you break your middle term down into your new numbers you just found. We know that negative 23x is equivalent to negative 2x and negative 21x. So we just replace the middle term with our new numbers we just found. And then you write it out, 7x squared, your new numbers, plus 6 equals 0, and then you factor it by grouping. From here, it must work out with factoring by grouping if you got the right middle numbers. The first two, the GCF, for these two terms is x, leaving a 7x minus 2. You can check x times 7x, 7x squared, x times negative 2, negative 2x. Then for the next two, you can factor out a negative 3. Negative 3 times 7x is negative 21x, and negative 3 times negative 2 is positive 6. Then, if you have factored by grouping, you should have a matching set here. So that becomes the GCF of those two terms. So you factor that out once, and then write the numbers that are left beside it, and that would be your factorization. You should always check these. If you do first, there's your 7x squared. Outer is negative 21x. Inner, negative 2x. And last times last, positive 6. The middle terms do combine to be the right middle term, so that works. So factoring. Let's try it one more time. Okay, so for our third example, I'm going to do one that's really has a lot more combos, that's a little harder to find the middle terms to show you how that process still works in all cases. I put these others with an equal to 0 if you were trying to solve an equation that you needed factoring in, but anyway, even if it's just a factoring problem, you're not trying to solve it, finish it by solving. Here's how you factor. Using this method again is the first times the last. So 20 times negative 21 is negative 420x squared. First times the last, that is. So you need something that multiplies to be negative 420x squared and adds to be positive 13x. And I do not know that off the top of my head, so I'm going to have to punch on my calculator a little bit. You can start with 1 if you like. 1 times 420 is 420. It's not negative though, so I need to make one side negative. I don't know which side it's going to need to be right now, but that's not going to work. Negative 1 times 420 is negative 420, but it does not add to be 13. So I keep going. Maybe it's negative 2. 2 times 210 is 420, but that does not subtract to be 13. So I keep rolling. Maybe 3. So I do 420 divided by 3. I made a note of that. That's 140. I'm not even close, right? So if you want to jump down maybe in the 20s, if you see you're just not even getting close. But if you just keep rolling, you may get there with that as well. You will get there eventually with this method, just marching down the factors. So 420 divides by 4, 105 times. That doesn't work. 5 goes into 120. 420. So I'm seeing it, I've got a long way to go. These numbers aren't even near subtracted to be 13. So I'm going to jump down, I don't know, maybe 15. I'm going to try 15. So I say 420 divided by 15. Oh, that's 28. Awesome. So 15 times 28 just so happens to multiply to be 420. I need one of these sides to be negative, so it multiplies to be a negative. If I put the negative on the 15, negative 15 plus 28 is 13. These need x's to make the variables correct. That multiplies to be negative 420x squared and adds to be 13x. Once you determine what works, and if you go through the whole list and you never find something, that means it's not factorable. But anyway, it will have a combination if it is factorable. Then we take our numbers that we discovered here that works for that. We change our middle term. We change it out to our new numbers in either order, the positive 28x. And we rewrite our problem with that changed out in the middle. Then it's factoring by grouping. There's no more guessing and checking. From there, it's a straight skill set. You bring out the GCF of the first two, which is 5x. For the second two, the GCF should be 2. Let's see. Oh, no, it's not. It's 7, isn't it? So 28, I don't know why I said that, but 28 and 21, the GCF is 7. 7 times 4x is 28x. And then 7 times negative 3 is the negative 21. If you've picked the right numbers, this thing has to work out here where you get a match. So expect that. That is your common factor that you factor out once. That's the GCF of these two terms. So we factor that out, writing it once, and then write what's in front of it for the other parenthesis. So we believe this to be the factorization of that. You always refoil it and check. Your first should be your 20x squared. Your last times last should be your negative 21. And then you're checking your inner, and your outer to see that it combines to be the correct middle term. All right, hope that helps. I'm done.